Let's discuss the question number 11 from test 3. It is from fluid mechanics. So let's read the question. A large tank open to atmosphere is filled with water to a height of 5 meters from the outlet of a tap. Okay, so the figure is given. You have a tap. Okay, and from the outlet of the tap to a height of 5 meters, the tank is filled. Okay, now this discharges water when it is opened. Okay, so tank is now open and the water discharges from outlet. So velocity at the outlet is asked. Okay, so from here let's measure Z. Okay, so yeah, so this is basically, let's use the Bernoulli's equation. Let's consider this as section 1 and this as section 2. So it's like a control volume which I have considered. This is my control volume. Okay, and so at section 1 let's use the Bernoulli's equation. So the Bernoulli equation, let's apply at section 1 and section 2. So this looks like this by Z2. Now Z1 is the height 1, Z2 is the height at 2. Now P1 basically it's atmosphere here, and here also you have atmosphere. Okay, so this and this terms, because P1 is equal to P2 is equal to P atmosphere, so this term will cancel. Now V1, because it's a large tank, so the area of cross section here, is very large compared to the area of the tap, area of cross section of the tap jet. Okay, so the velocity V1 is almost 0 because of that large tank thing. Okay, so now what is left is Z1 is basically 5 meters and Z2 is 0 because it is the reference level is the tap. Okay, so let's plug in all this thing in this, and because P1 is P2, so this term will get cancelled. V1 is 0, so Z1 is 5 and V2 square by 2G, Z2 is 0, so V2 is 2G or 2 into 9.81 into 5 and then the root over this when you find out it, you get something close to 9.9 meters per second. So the option is B. Thank you.